This next technique is the most commonly used technique that you see everyone doing throughout video games, VFX, animation, you name it. It's using bitmaps, or texture maps, or BRDF maps, some folks will say. And all of this relies on UV coordinates that are applied to the mesh. I'm sure many of you guys have already used UV coordinates before. You've probably used a texture map here or there on something. But just in case you haven't had a great definition of what UVs are, let's start off by defining those and then giving the pros and cons with this particular approach. So what does UV mapping actually mean? Well, UV mapping is also referred to as UDIM mapping, and UDIM stands for U dimension. In 3D graphics, we use XYZ, and that's on our points to define where things exist in space. Well, with UDIM mapping, we do the same exact thing, except now our coordinates are U, V, and W. Now, with UDIM, we want to do something different than XYZ. XYZ is there to describe where something is in 3D space. It's what our viewports use. It's what the render engine uses to determine where it is. But with U, V, and W, we want to understand where our mesh exists within a 2D space. So if we take away the W, that leaves us with UV. That's a two-dimensional data scheme, right? And if you think about creating a flat plane with U in the horizontal direction and V in the vertical direction, that gives us what we need to flatten things out in 2D and paint on whatever the geometry is. So whenever we have this geometry that starts off in XYZ space, we can then assign the vertices, which are associated with the faces, the primitives, along these U and V dimensions. And now we have objects that can be understood in 2D space. So at the end of the day, when something is UV'd, you have the object in 3D space, that's XYZ, and then you have it also living in 2D space, that's with UV, to understand where it lives. And the reason why we don't use X in this horizontal direction and Y in this vertical direction is because those are already being used to describe where something is in 3D space. So that's why we use U and V instead. So now once we have a texture map and we assign it to this U and V dimension, we now have a way of taking the pixel values, the actual colors of those maps, and if it overlaps where these primitives have been assigned to, then that can control the shader values and break up the different values through a map. Now there's various pros and cons with this. The pro is that if we use a variety of texturing applications, we have all kinds of options. So, if you have Substance Painter, Mari, Quixel's Mixer, 3D Coats, there's all kinds of different applications that allow you to paint on the surface, which is really cool. We also have very easy access to parts of the mesh through these UV islands. So once something has been laid out in UV space, if you want to, let's say, select the bolts on an airplane, you can organize the bolts in a way that makes it easy to select via this UV space. Also, it could sometimes be useful for describing the directionality of a mesh. So an example of that would be if you had, let's say, a tree and the bark has a specific direction on that tree. If you lay out your UVs accordingly, you can have, let's say, all the branches and the trunks going vertically, and then that can line up with the vertical direction of a texture, giving you the ability to create directional patterns through the UVs. And so, yeah, that could be a very useful thing at times. Also, it's very easy to update. So if you want to change anything, you just switch out the texture and that'll change what you get. And it's also the most common technique that can be used with any render engine. So this is the most common technique. Pretty much every studio does this particular technique at some point. But this also comes with cons. The cons here is that with UV mapping, it's very labor intensive. Laying out good UVs can take time. And even though we do have some very sophisticated auto UV options, it's not always going to work to do the auto UV. There are situations where you can get away with auto UVs, and I'll talk about what those situations are here in the future. But for the most part, I would count on UVing to be a labor-intensive process. It's also not easy to get the right amount of resolution either. So what I mean by resolution is the actual dimensions of these maps. If, let's say, you have a 1K map, which is a 1024 by 1024 resolution, that might work well for something that's far off in the distance, but it's kind of difficult to tell sometimes how much resolution is ideal for certain objects. You don't want too much because then that slows everything down, but you also need enough so that it's not going to get pixelated. And so that always becomes a very delicate balance. Also, another con is that it can create texture seams. And this can be a big problem whenever you're bitmapping or painting on an object. And what I mean by seams is that if you have these UV islands and you ever notice a line, like a strange incontinuity between what the texture patterns are along these edges, that is what a texture seam does. And I'll also talk about bitmapping in the future. If you already know what bitmapping is, what happens is that when it goes down in resolution, it'll create these seams that become very noticeable, and it's due to a filtering issue. Also, editing the model after texturing can be a problem. If, it depends on how much you change the model, but if you edit the model after it's been textured, you'll most likely need to go back and redo the UVs for that area, and potentially redo the entire texturing process if that happens. Also, seam areas, like I mentioned before, can cause problems, especially with displacement maps. And so that's a very common issue to run into, especially when it's a byproduct of filtering, or incorrect filtering, that is. And then texture stretching can occur, especially along the beveled areas. If you're working within VFX, animation, film, something like that, then you'll most likely be working with subdivided models, and that can cause some stretching once things go to subdivide. And lastly, it can also occupy a large amount of files, disk space, and require strict file management. If, let's say, you're working on a team and you have 5 people texturing, then you might have thousands of these maps being saved to a server somewhere, and that can create a problem just by having a large bottleneck of files. And on top of that, it can also be a big challenge if one person messes up the organization, and it could kind of turn into a mess if you're not careful. So there you go. That is some info on bitmaps. Now, most folks will stop their understanding of shading techniques with bitmaps because it's the most widely used shading technique out there. However, for myself and some other texture artists, it's not really the most ideal way of working. The main con being UVs, and that it's also not easy to get the right amount of resolution, and these texture seams can get fairly annoying. At least for myself, that's the main reason why I don't prefer using bitmaps. In the next video, let's take a look at how you can create these bitmaps. There isn't one approach to take. You can use texture painting applications, you can create repeatable textures in Photoshop. There's multiple ways of doing this. So we'll examine that and make something look awesome.